question is, haven't written any vector symbols here. If I put a vector symbol there, the question is, what is the direction? Because vectors have a magnitude and a direction. So what is the direction of that acceleration? Well, I'm going around a curve here. Let's say I'm going in that direction. At this point right here, what is the direction of my velocity? Like, straight that way? That's what you're going for?
That's what I'm guessing.
More like,
And you're saying more like that?
yes.
Well, we can sort of demonstrate this. If I have my stopper on the string, which I do. If I swing this thing around, if I let go, which way is it going to go?
The direction.
Direction, where did it go from?
Meaning,
Sorry.
if I let it go when it's right here, which way is it going to go?
That one straight away.
So we have a straight back and we have a that way, and all right, let's see what happens. I've never hit a student doing this. Especially did not hit Scott. And the reason I'm bringing that up is I got closer to Scott than I intended. But word circulated in the school that I hit Scott. All right, so 3, 2, 1. From Newton's first law of motion, an object will continue doing whatever it's doing unless something causes it to stop that. Now, it didn't go straight, it did curve downwards because there was the force of gravity downwards. But it does move in the direction in which it was released. And so it moves tangent, so the velocity at this point is tangent. At this point right here, it is tangent. I can draw it properly. So I have some initial velocity here, I have some final velocity there, and I know the difference is by changing velocity. So I'm going to take my initial velocity, my final velocity. I know the initial velocity plus the change gets me to my final. So that's the direction of my change. What I'm saying here is that this acceleration is towards the middle of the circle. Now, of course, we have a shorthand way of saying that as opposed to having to write out towards the middle of the circle. Have we talked about the radial unit vector? I hat, j hat, I hat, we decide which direction that is. J hat, we decide which direction that is, other than it's perpendicular to I hat. K hat is set in right-hand coordinate system. R hat's a little bit different, it's special unit vector. R hat is a vector, unit vector, pointed away from the center. The acceleration here is pointing towards the center, so I would write that, to write it formally. Now typically, you just find the magnitude and think through the direction, but formally, it'd be, if R hat is away from the center, and this is pointing towards the center, it's the negative. So negative v squared over R hat. That's the more formal way of writing it. The C stands for centripetal. It is not that other word that most people would use. I will talk about it briefly right now. The other word is centrifugal or centrifugal. That is misused most of the time it's used. So I would recommend cast it from your vocabulary for the moment. There is a proper way to use it, but in this class, we will be talking about centripetal. Coming from the word for center, and then PET, similar to competition. You have two teams that come together seeking each other out. Centripetal or centripetal means center seeking. That other word, center, and then what word do we have meaning trying to get away from? With that same root? Fugitive. There's also a cliche of tempus fugit, which means time flies. This is center fleeing. And this potentially is the last time I ever use this word in this class. This is the one that we're talking about. And on that note,